Hello and welcome to another Common Core Algebra 1 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be doing Unit 4, Lesson 5, Writing Equations in Slope-Intercept Form. Before we begin, let me remind you that you can find a copy of the worksheet that goes with this video and a homework set by clicking on the video's description, or by visiting our webpage at www.emathinstruction.com. Also, don't forget about the QR codes. Scan those with your smartphone or your tablet to come right to the videos. Alright, let's begin. In previous lessons, we've been looking at graphing lines, getting a feeling for what it means for a point to be on a line, etc., etc. Today, we're going to be writing the equations of the lines, and so I want you to make sure that you understand the form of a line and the linear parameters. Okay, remember, function notation, f of x equals y. The function and y are the same. That's true of anything, not just lines. But then there's two parameters. There's m and there's b, right? Two constants that go into the equation. M is that average rate of change, also the slope, also the change in y divided by the change in x. Okay? The b, though, that's the y-intercept of the line. I like to think about it as where the line starts, right? Where it's at when x is equal to 0. Okay? I'm going to clear out that little bit of text, and we're going to jump right into writing the equations of lines. Let's do it. All right, exercise number 1. I'm going to go back to blue, I think. Red's nice, but I'm in a blue mood right now. Letter A says, determine an equation in the form y equals mx plus b for this equation. And it should actually say for this line. That's a little bit weird. Anyhow, we want to write an equation for that line. And we really have to just figure out two things. We have to figure out the slope, and we have to figure out the y-intercept. Now, the y-intercept's pretty easy, especially in this example, because it's right there, right? So that's simple enough. The y-intercept is 2. On the other hand, what's the slope? There's a couple different ways we could do that. We could pick 2 points off of the line, and we could then do the average rate of change, or the slope formula. Or we could try to do it graphically, which is what I'm going to do in this case. I'm going to find another point that lies on the line, and that's a good example. And I'm going to figure out its run and its rise, right? So what I can see in that particular situation is that the change in x was a positive 2 because we moved to the right, and the change in y was a positive 3 because we moved up. So our slope must be 3/2, the change in y to the change in x. Always the change in y divided by the change in x. Rise divided by run. How many different ways can we put it, right? Well, that's it though. Now we can write the equation of our line. Y equals 3/2 times x plus 2. Don't forget the x. All right, I've seen many students who do everything perfectly. They end up having a beautiful slope, a beautiful y-intercept, and then they write something like this down. Now, it could be that in the past, you might have gotten, on a Common Core exam or on a normal Regents exam, you might have gotten a lot of credit for that. These days, that might be a full loss of credit, because quite frankly, that's a horizontal line. That's y equals a constant. So don't forget the x. It's kind of important. Now, notice letter B says, test your equation for a value x equals 2. So what that means is that if we take 2 and we substitute it into our equation, it should predict the correct y value. Well, these two 2's cancel, and that just gives us 3 plus 2, or 5. Now, is that the point here? Well, let's see, 2, 1, 2, 3, 4, 5, you bet. Right, the point 2, 5 lies on that line, so we have it. All right, and that's a good thing to note. Anytime you write the equation of a line, or anything else, grab a point that lies on that curve, substitute it into the equation, and see if it gives you the right coordinate pair. All right, I'm going to clear this out, and then we're going to go on and work on a harder one, okay? Here it goes. Let's take a look at a more difficult problem. Exercise number 2 gives us this line, and it says find the equation of the linear function shown in slope-intercept form. Now it's important that you actually know the terminology. So when you see something that says slope-intercept form, the first thing you want to do is write down y equals mx plus b. And then we're going to test our equation for x equals -4. Now, pause the video now and think for a moment why this is now harder than the last problem. All right. Well, it could be harder for a variety of reasons. Number one, it could be harder because the slope's negative, and people might make a mistake on that. But what I find very difficult about this problem is that the y-intercept is certainly not an integer. Now, some people might look at that and go, well, the y-intercept's clearly 1.5. Don't go there. Maybe it's 1.5, maybe it's not 1.5, right? We don't know for certain. So we're going to figure out a way to come up with that y-intercept exactly. But first things first, let's figure out the slope. Now that we can do graphically, because we can pick off 2 points that lie on the line. Let's say we pick that point and that point. Okay. And what we can see is to go from these 2 points, right, to go from left to right, we'll have a delta x of 3. Now here's the tricky thing. But we'll have a delta y of -1. -1, not +1. That's because the line has a negative slope, or it at least results in a line with a negative slope. So the slope of this line is -1/3. But again, we're still left out in the dark on our y-intercept. So here's the key, and this is what I always told my students when I always tell my students, when I teach algebra. If you know a piece of a puzzle, put it into the puzzle. All right? So right now, here's what I'm sitting with. Y equals -1/3 x plus b. The question is, how do I find that b? And the way you find it is the same way you do it each and every time. And in fact, this is a bigger picture. Often, when we are missing a parameter, one parameter and only one parameter, the only thing we're missing right now is the y-intercept from a curve, then you pick any point that lies on the curve and you substitute it in. Let me in fact pick a point that we haven't worked with yet. Let me take the point 2, 1. See, this point lies on this line. We know from previous lessons that that means that this point, when you substitute it in, must make the equation true. All right? So this must be a true equation because that point lies on the line. But notice the only thing that is left is our b. Now 2 times -1/3 is -2/3. And now I can solve for b by using a little bit of, that didn't work very well. I can use a little bit of the additive property of equality and add 2/3 to both sides. Let's work in fractions here. All right, 1 is the same as 3/3 plus 2/3. So we find that b is 5/3. Remember, when adding fractions, you need a common denominator, and then you simply add the numerator. But there we have it, right? So we can now say that the equation of our line is -1/3 x plus 5/3. Of course, what makes this much more difficult than the last one is all the fraction work. And fractions can be confusing. They can be, right? They're one of the most confusing things about middle school and elementary math. But the beautiful thing is we can now test this, right? We can test it, and we're asked or told to test it with x equals -4. Now, what do we know about -4? We know that the point -4, 1, 2, 3 lies on our line. Right, that's this thing right here, that point. So what I'm going to do is I'm going to put -4 into my equation for x, and I'm going to see if it gives me +3 as an answer. Right, I got to come out with that. Don't forget that a negative times a negative is a positive, and -1/3 times -4 is 4/3. Remember, when multiplying fractions, you simply multiply the numerators, multiply the denominators. Plus, it just makes sense. If I have 4 times 1/3, I have 4/3. Think about that a bit. So we'll have 4/3 plus 5/3, which is 9/3, and 9/3 is the same as 3. So it checks. All right, it is more difficult, but it's a great way to find the equation of a line. Find the slope, either graphically or by using the slope/average rate of change formula. Then pick any point that lies on the line, substitute it back into the equation of the line, and solve for the y-intercept. I know it's multi-step, but hopefully it makes sense and we'll get a little bit better at it in a second, okay? All right, write down what you need to, and then I'm going to clear out the text. Here we go. All right, next problem. So we just want to do a bunch of these. Find the equation of the line that passes through each of the following pairs of points in y equals mx plus b form. All right. Now, every time when I do these problems, what I'm going to do is I'm going to figure out the slope first, and I'm going to use that average rate of change formula, but I think I'm going to write it in what's known as the classic slope form. All right, y2 minus y1 divided by x2 minus x1. So I'm going to call this x1, y1. I'm going to call this x2, y2. So I can find the change in y by doing 17 minus 5. I can find the change in x by doing 5 minus 2. So my slope ends up being 12 divided by 3 for a slope of 4. Great. Remember, every time you have a piece of the puzzle, put it into the puzzle. I now have y equals 4x plus b. I can now pick either one of these 2 points. It doesn't matter which, I might as well pick the first one. I'm going to put 5 in for y. I'm going to put 2 in for x. I'm going to get 5 is equal to 8 plus b. I'm going to subtract 8 from both sides. Be careful. 5 minus 8 is negative 3. So I can now say y is equal to 4x minus 3. And there's my equation. A really good way to test whether you've got the right equation is to then see whether the other point, the one you didn't use to find b, actually still makes the equation true. If it does, you have the right equation. All right, I'd like you to try letter B on your own. Follow letter A step by step and see if you can get the linear equation that passes through those 2 points. All right, let's go through it. Again, I'm going to call this one x1, y1, this one x2, y2. My slope now, y2 minus y1 divided by x2 minus x1. 3 minus 5, right? y2 minus y1 divided by x2 minus x1. Be very careful here, very careful here. All right, 3 minus 5 is negative 2. Remember, when we subtract a negative, it becomes a positive, so it becomes 2 plus 2 is 4. I can now divide both top and bottom by 2, and I'll find that my slope is negative 1/2. Not quite as nice as my last one, but if I have to deal with a fraction, 1/2 is as good as it gets. Negative 1/2, not as good, but still pretty easy to deal with. All right, I'm going to take the first point, and I'm going to throw it in there. So I'm going to take my negative 2, 5, and chuck it into this equation. I think I'll do a lot of arrows today. All right, make sure you're putting in the right values for the right variables. It's always embarrassing to put in the x for the y and the y for the x. All right, a negative times a negative is a positive, and 1/2 times 2 is 1. All right, the rest of this is going to be pretty easy. Subtract 1 from both sides. We get b is equal to 4, and y equals negative 1/2 x plus 4. There it is. All right, let's keep going. What I'd like you to do is pause the video right now, think hard about what you've seen. It's a step-by-step procedure. It's the same steps again and again and again, but they're very, very important. So let me clear this out. All right, here we go. And let's do a couple more. Some of these are going to get a little bit more ugly than other ones depending on the fraction work. Okay, let me go through C again. I'm going to call this x1, y1, x2, y2. So I'll do C and then have you do D. Okay. Let's again figure out the slope first. y2 minus y1 divided by x2 minus x1. That'll be -4 minus 11, y2 minus y1, divided by x2 minus x1. Again, watch out for the double negative. Okay, -4 minus 11, again, a little bit tricky, -15. 4 plus 1 is 5, and that gives me a slope of -3. I keep doing the ones with the nice slopes. Sorry about that. But I get y equals -3x plus b, right? I can now take this point, substitute it in. I'll put 11 in for y, -1 in for x. Of course, -3 times -1 is +3. Subtract 3 from both sides. Boy, this seems repetitive, doesn't it? And b ends up being 8. So at the end of the day, y equals -3x plus 8. Remember, make sure you have that x in there. You know, that guy right there. All right, pause the video again, see what you can do on letter D, and then we'll go through it. All right, let's do it. I'm going to see if I can write this down without having to write all the y2, y1s down. All right, 19 minus 4, right? 19 minus 4 divided by 12 minus 3. All right, 19 minus 4 is 15. 12 minus 3 is 9. Now we could leave it that way, but I always find it easiest to work with fractions in their most reduced form. 15 divided by 3 is 5. 9 divided by 3 is 3. So I get not the greatest slope on earth, 5/3, but whatever. I can deal with it. It's just a fraction. So y equals 5/3 x plus 3. Sorry, that almost looks like an 8. Let me make sure that there's no confusion there. All right, 5/3 x plus b. Let's take this thing, substitute it in. We'll get 4 is equal to 5/3 times 3 plus b. Here the 3's will cancel. 4 will be equal to 5 plus b. Subtract 5 from both sides, and be careful, 4 minus 5, -1, is what we have for b. So y equals 5/3 x minus 1. As an aside, if you went through the whole problem with that 15/9 and you got this, y equals 15/9 x minus 1, that's completely okay. All right, those are both good answers. I like the reduced form of the fraction, but it's not a problem if you have 15/9. I will say if this was a multiple choice question, they would certainly have the slope reduced. All right, pause the video now, write down what you need to, and then we're going to move on. Okay, let's do it. So, one more problem, nice applied problem. We're going to be doing a lot of linear modeling in the next 2 lessons, so this is just a little taste of it. A car is traveling along a straight road. After 1 hour, the car is 72 miles from Chicago. Okay, fair enough. 1 hour, the car is 72 miles from Chicago. After 3 hours, the car is 188 miles from Chicago. Determine an equation for the distance d the car is from Chicago after h hours if the relationship between d and h is linear. Now notice, the distance, that's the output, right? That's the output, right? That the time, that's the input, okay? So in a certain sense, what we're doing is, well, actually, let me write y equals mx plus b down first. Y equals mx plus b, but now we have distance equals m times the number of hours we've been driving, plus b. Okay, we still have to figure out m, we still have to figure out b. You might say, well, we don't have any points, but we do, right? What are our 2 points? Well, we know after 1 hour, the car is 72 miles from Chicago, and after 3 hours, the car is 188 miles. Now we can come up with everything we need, right? The slope is going to be 188 minus 72, all divided by 3 minus 1. And here what's nice is that you actually have, whoops, did the subtraction wrong in my head. You actually have some nice physical basis for what's going on, right? We've driven, between these two periods of time, we've driven 116 miles. Watch, I'm going to track the units a little bit, even though we don't need to. And we've driven for 2 hours. Obviously, we can then reduce that. Sorry, I have to get my cheat sheet out. And we can find 58. Now, again, although the units aren't absolutely necessary, it's kind of cool because what we really have here is 58 miles per hour, right? The speed that the car is driving at, that's all. But now we can throw that into our equation. D equals 58h plus b. Still have to figure out b. So I could take my point up here, or my second one, it doesn't matter which. Throw it in. This one's particularly nice because 58 times 1 is 58. And now I can subtract from both sides, and I can find that my y-intercept is 14. So my equation, D equals 58h plus 14. Again, one of the great things about an equation like this is that you could easily test with either one of these 2 points. All right? Great. Pause the video now, copy down what you need to, and then we're going to finish up the lesson. Okay, here goes the text. Okay, so today we really primarily concentrated on how to write equations of lines given either their graphs or 2 points that lie on the line. And of course, the 2 points that lie on the line, that's a lengthy procedure, right? We calculate the average rate of change, also known as the slope. We then put that slope into the equation. We pick one of the 2 points that we have, substitute that into the equation, and come up with our y-intercept. It's a long procedure, but it's one that you'll do year after year in mathematics. It's critical to know how to do it for linear modeling, and we'll get a lot of practice on it in the lessons that come. For now, though, let me thank you for coming and joining me for another Common Core Algebra 1 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.